again. So in this third part of the video, we are actually going to look at solving these basic trig equations, but in this time in radians. So rather than looking at degree values, we're going to look at our radian values. So here we have sine theta equals negative rad 3 over 2. The process for these are basically the same as the degree ones. I'm just going to be reinterpreting my angles in terms of radians rather than degrees. So to get rad 3 over 2, I'm going to need a reference angle for sine as 60 degrees. Because again, we're in radians, I'm going to reinterpret that as pi over 3 radians. The quadrant that I will be dealing with, because I have a negative trig value, it will have to be the quadrants in which sine is negative. So a smart trig class, our acronym for remembering the signs, all values positive, sine positive, cosine and tangent positive, sine and cosine negative, cosine positive, sine and tangent negative. The two quadrants in which sine will be negative will be the third or the fourth. Okay, so I could be in quadrant 3 or 4. From here, I'm going to have to throw a pi over 3 angle in each of those quadrants. And I'm going to interpret them, in each of those cases, my two quadrant answers. So here I'm going pi over 3 past pi. Now pi is really the same thing as 3 pi over 3. And if I'm going 1/3 past that, I'm increasing by one more third. I should have 4 thirds altogether. So that would be my quadrant 3 answer. Over here, I have pi over 3 back from 2 pi. Now 2 pi is 6 thirds. And if I'm going 1/3 in the negative direction, I'm really going to get 6 thirds minus a third, which altogether should give me 5 thirds. So my fourth quadrant answer should be 5 pi over 3. Okay, same process that we did with degrees. I'm just now having to deal with radians. And to help, I'm getting common denominators with my reference angle so that I can more easily compute the two values. Okay, let's look at another example. Here, cosine equals 0. Now this is one of those special ones. Whenever I see sine or cosine equaling to 1 or 0, I know that I'm going to have to use my unit circle because it's not going to come from one of the two special right triangles. Again, the coordinates x and y on a unit circle, a circle with radius 1, are equivalent to the values of cosine and sine respectively. So I'm looking for where cosine, the x value, is 0. So the x values would be 0 at this coordinate and this coordinate. So at the coordinate 0, 1 and the coordinate 0, negative 1. For both of those, the x value or the cosine value is 0. So this puts me at 90 degrees, which in terms of radians is pi over 2, and at 270 degrees, which in terms of radians is 3 pi over 2. And those are going to be my two answers, so I don't have to use a reference angle process if I'm using the unit circle. My two answers are pi over 2, and the equivalent of 90 degrees, and 3 pi over 2, the equivalent of 270 degrees. The last example that I want to look at in terms of doing these in radians is cosecant squared equals 4 thirds. Now this one's a little bit more involved because it's not basic per se. I have to do an operation to help me identify my values. Okay, so the first thing I'm going to do is I notice that this is cosecant squared. And if you remember function notation, all this really means, cosecant squared, is that I'm squaring the actual function. So cosecant squared theta really means the value of cosecant theta, quantity squared. So it's not that I'm squaring the angle, I'm squaring the function. And the reason we put the 2 next to the function name is so that we don't confuse squaring the angle with squaring the function's value. Okay, so to help eliminate that square, I'm going to take the square root of each side of this equation. And I have to interpret that solution that I could have a positive or negative value when I'm taking square roots, because both the square of a positive and negative will both give me positive 4 thirds. In doing that, I get cosecant theta, because the square root and the square, they're going to cancel each other out, will give me positive or negative square root of 4 is 2 over square root of 3. Okay, and again, just like before when we're dealing with any of the reciprocal functions, cosecant, secant, or cotangent, I like to reinterpret these in terms of their reciprocal functions. So for cosecant, that will be sine. So sine of theta will be plus or minus the square root of 3 over 2, the reciprocal of this ratio. So this one's kind of interesting because I have both positive and negative. So if I think about that A-smart trig class, those positive values, well, that'll be quadrant 1 and quadrant 2, but the negative values, well, that'll be quadrant 3 and quadrant 4. So I wind up in this particular example, I could be in any of the 4 quadrants. I could be in all 4 quadrants, which means I expect 4 answers to this problem. The next thing I'll need to do is interpret the reference angle. So now if I have rad 3 over 2, that is a 60-degree angle. Or again, since we are working in radians, I'll write that as pi over 3. Okay, so I have to do pi over 3 in all 4 quadrants. So in the first quadrant, I get pi over 3. In the second quadrant, it's going to be pi over 3 short of pi, or 1/3 short of pi. Give me 2 pi over 3, or 2/3 of pi. In the fourth quadrant will be 1/3 past pi. So it's 1 and 1/3, or 4/3. So give me 4 pi over 3. And in the fourth quadrant, it's 1/3 short of 2 pi. If it helps, you can think of 2 pi as 6 pi over 3. And if I go 1/3 short of that, I'll wind up at 5 pi over 3. So I wound up with pi over 3 in each of the 4 quadrants. So I wound up with 4 answers. Again, the reason for that is I get 2 answers from the positive value and 2 answers from the negative value. So altogether, I have 4 solutions to this problem. In the next part of the series, we're going to look at the general solution. So what if I don't give you a specific interval and I ask for all of the possible answers? That's what we will look at next time.